So in red here, we have the graph of y is equal to x squared minus 3. And then in blue, we have the graph of y is equal to x to the fourth minus 4x squared plus 1. And the goal of this video is to use our knowledge of calculus in order to find this area between the graphs that is shaded in yellow. So like always, pause this video and see if you can figure it out on your own based on what we know about the area between curves. All right, so now let's figure it out together. So we can see over the interval where this blue area is relevant. We're going from one point of intersection to another. And it looks like it is x equals -1 to x equals 1. But we'll verify that in a second. But over that interval, it looks like the blue graph is above the red graph. The blue function is above the red function. And so we know from previous videos that this area could be expressed as the definite integral, and I will confirm that the bounds are from x equals -1 to x equals 1 in a second, but let's just go with it. It looks like that, x equals -1 to x equals 1. And so for that interval, we would take the graph that is greater than, that is above the other graph, and so that looks like the blue graph over that interval. So we would say that is equal to x to the fourth minus 4x squared plus 1. And then from that, we would subtract the graph that is the bottom boundary of the area in question. So then I would say minus, and I would subtract the red graph, or the equation of the red graph, x squared minus 3. And then, of course, we would have dx. So let's just confirm the boundaries first. Let's just confirm that we have points of intersection at x equals -1 and x equals 1. When x equals -1, the red graph is 1 minus 3, which is -2. And over here we have, let's see, -1 to the fourth is still 1 minus 4, which is -3 plus 1. Yep, that is -2. So -1, -2 exists on both graphs. Let me make that a little bit clearer. And you use the exact same argument if you plug x equals 1 here. In both cases, you would get y is equal to -2. So those actually are the points of intersection. And so that actually will be our bounds of integration. And once again, we made the blue function, but we are subtracting from that the red function because over that interval, the blue function is greater. So now let's just actually compute this. So what is this going to be? And at any point you get inspired, pause the video and figure it out on your own. So this is going to be, let's see, we have an x to the fourth, and we have minus 4x squared, but then we're going to subtract another x squared when we distribute this negative sign right over here. So if we have minus 4x squared minus another x squared, that's going to be minus 5x squared. And we have a plus 1. And then we're going to subtract a -3, which is plus 3. So then 1 plus 3 is plus 4 dx. And now we take the antiderivative of this inner expression. So this is going to be x to the fifth power divided by 5. Just the reverse power rule. Increment the exponent and divide by that incremented exponent. Minus 5x to the third over 3. Just doing that again. Minus 5x to the third over 3 plus 4x. We're going to evaluate that at 1 and -1 and then find the difference. So if we evaluate that at 1, we are going to get 1/5 minus 5/3 plus 4. And then from that, we are going to subtract all of this evaluated at -1. So that is going to be, so minus, see, -1 to the fifth over 5, that is -1/5. And then minus, we have 5, so this is going to be -5/3, but we have a minus out there, so plus 5/3. And then 4 times -1 is -4. But then we're going to distribute this negative sign. So this would be, if we distribute it, we can make this a plus, then this would be a plus, this would be a minus, and then that would be a plus. I just distributed the negative sign. And so you have 1/5 plus 1/5. Let me just do this in a new color. 1/5 plus 1/5 is going to be 2/5. And then we have minus 5/3 minus 5/3. So that's going to be minus 10/3. and then we have 4 plus 4, so plus 8. And so now we just have to deal a little bit with a little bit of fractions here. So let's see, this is going to be equal to, I'll just write the 8 again, 8. And then we're going to have, see, common denominator 2/5 is the same thing as 10/15. So plus 10 over 15 minus, let's see, if we multiply the denominator here by 5 to get to 15, the numerator is going to be 50/15. Let me scroll down a little bit, get some more real estate. All right, so this is going to be equal to 8, 10 minus 50, so this is minus 40/15. And let's see, this is the same thing, 40/15, divide them both by 5, that is 8/3 minus 8 over 3. 8/3 is 2 1/3, so this is equal to 8 minus 2, or sorry, 2 2/3. 8 minus 2 2/3. So 8 minus 2 is 6, minus 2/3 is equal to 5 1/3. Square units, because this is an area. So there you go. Using calculus, the power of the definite integral, we have been able to figure out this area of this fairly strange region, the strange shaped region, I should say.